Good afternoon, sir. My name is Koel Devnath. I am from DS2A. Today I am going to present on my project Web-based visualizer for structural representation of C program. We know that computers do not treat source code as plain text. Programs are analyzed through multiple stages before execution. This project visualizes the internal representation of C program. The system generates tokenization, AST, CFG, DFG, and CPG graphs. It demonstrates concepts used in compiler and AI code assistant. Here the problem statement we are demonstrating in. Most of the beginners find difficulty to visualize how a program is processed internally by computers and AI tools. So this project will help them to analyze easily using the graph that those are AST, CFG, DFG and simplified CPG. So through this they can understand the program structure, execution flow, data dependency and the techniques used by modern AI code assistant to analyze the source code. The main objective of the project is to analyze the source code, means C program, to generate AST, CFG, DFG, CPG representation graphs, to understand program execution and data dependency, to study the application of automata theory in code analysis, to understand how AI code assistants process the source code. So next, coming to the first phase of the compiler design, that is tokenization. It basically breaks the source code into small meaningful units called tokens. The main objective is to identify keywords, identifiers, operators, constants and symbols from the source code. Here's the example. Here we have given one line code, that is int a equals to 10, and corresponding tokens and their type have been written here. So the main importance of this is to remove the unnecessary space and comment. Next, coming to the next phase, that is abstract syntax tree. In short form, it is known as AST. It represents the syntax and hierarchy of a program. The main objective is to represent the logical structure of the code in hierarchical form. So here's the example and the diagram. Next, the main importance is it is used to for code optimization. Next phase is the control flow graph. It shows the possible execution path of a program. It is helpful to represent how control moves from one statement to another during execution. So here's the example and the corresponding graph. The main importance is to show program flow execution. Next is the data flow graph. It represents how data moves between variables and operation. The main objective is to identify data dependencies and the relationship among variables. So here's the example and diagram. Important is to useful in detecting redundant computation. Next, the last phase is the code property graph. It mainly unified graph that combines AST, CFG and DFG in a single representation. The main objective is to complete structural control flow and data flow information in one graph. So here is the AST, CFG and DFG graphs. It combines and generate the CPG graph. The main important is to combine structure, flow and data in one model, and used to security analysis helps detect vulnerability in code. Next, coming to the connection to automata theory. It forms the foundation of compiler design. Finite automatas are used in tokenization. Grammar rules helps generate AST. Program analysis techniques are based on formal language concept, demonstrate practical application of automata theory. Next, connection to AI code assistant. AI tools like ChatGPT, GitHub, Copilot, Gemini. How they use this concept means tokenize source code, understand structure using AST, analyze execution using CFG, track variable dependencies using DFG, and generate explanation and code suggestion. Here is the output. Next, this is the output. We will see this in the demonstration part. So Here is the code of the project. Here contains some folders and files. Here built, it contains the final production node modules, stores all the installed React, and public it contains static files. Source it is the main source code of our application. AST will display the AST, that is abstract syntax tree. It displays the control flow graph. DFG displays the data flow graph. CFG displays the control flow graph. CPG displays the code property graph, and tokenization means it displays a list of lexical tokens generated from the C program. Here utilizes means it is the core analysis logic. It generates tokens AST, CFG, DFG, and CPG. The main file is the app.js. It is the main React component. It contains UI, sample, program, tabs, and analyze button. Here app.css it's used for styling for the application, and index.js is the entry point of the React application, and render app.js into the browser. Index.css is a global CSS style. So here is the code of app.js, that is the main function. Here import components means token table. It displays the lexical token. AST view it shows the abstract syntax. CFG view it shows the control flow. DFG view it shows the data flow graph, and CPG view it shows the code property graph. And analyze code, it processes the C code and generates the analysis result. Here is the sample program. There's a basic C program, if else program, loop, swap, while loop. Here is they are all the sample programs. Next, coming to the state management, which is a use state, which contains code source, stores the C code tab that stores the currently selected tab, result stores analytic results, functions handle sample. Handle sample means loads a selected sample program. Handle analysis calls analytic code and generates token AST, CFG, DFG, and CPG. Here user interface means left panel selects a sample program that we will see in the execution demonstration part. So let's execute this program. So here is the output of the code. So here it is the UI. First we will select the sample program. Here we can choose anything, for loop, while, variable. So we will choose if else loop. Here is the sample code, C code. We can insert another code also if we do not want this. Then we will analyze the program. Here the tokens are generated. That is the lexical analysis. This is the output of the lexical analysis. It breaks the source code into tokens. So here is the tokens, and here is the categories. Next, coming to the AST tree. So here it shows the hierarchical structure of the program. Here program functions, int, if, all it is shown. Next, coming to the CFG graph. CFG graph shows the execution path of the program. Here start, then int, number, print, then return and end. Then coming to the DFG graph, that is data flow graph. It shows the constant and variable flow through assignments, operator, conditions, and functions. So here it is given, and that is 10 with int number, like this. Then coming to the last part, that is CPG graph. It shows the combined form, that is AST, CFG, and DFG graph. And these three graphs combine the CPG graph. Here blue indicates the AST edge, green represent the CFG edge, and red dashes represent the CFG edge. So this is about the four graphs and tokens. So here is the interface. Here we can insert another program also. For example, if you want to change it like this, so then we can get the corresponding graphs. So for this program we will get like this. This is the AST, this is the CFG, this is the DFG, and this is the CFG graph, CPG graph. So concluding with this, so here we successfully demonstrated the four types of graph, that is AST, CFG, and CPG graph for any basic C program. Thank you.